welcome back, everyone. Our next speaker is Michael Gribben. Michael Gribben is going to be talking to us about a talk called Beyond the Hype, Using AI Coding Agents Today. Over to you, Michael.
Thank you.
Big round of applause, please.
Hello, I'm Michael, and I have about 4 years of experience as a software engineer. And for slightly less than one of those years, coding agents have been a thing. And that's what I want to talk about today. I want to make you slightly more productive at your job using coding agents. Now, as I've learned yesterday, watching the Data and AI track, every talk mentioning AI has to mention the elephant in the room. There was a lot of hype about AI and about coding agents. And by a lot of hype, I mean like a lot of hype. Like some people think there will be no more software engineers by 2026, which is a bold bet to make given 2026 is like 4 months away. So I don't know about you though, but I've seen this type of hype before. Does anyone remember GitHub Copilot? Quite a few people, yep. So I do, and I want to tell you a story. So back in 2021, I was in my last year of university, and I was in on a meeting with a bunch of academics, and we watched GitHub Copilot, which had been released that October, ace a first-year programming assignment in one shot. There was a lot of like fear, uncertainty, and doubts, and a lot of hype back then. Like, what could GitHub Copilot not do? And it turns out, like, actually quite a lot. I have no doubt that it helped get few students cheat on assignments. That was a problem. But it didn't radically change coding. Like, didn't radically change how I coded. And I haven't heard of like mass job losses thanks to GitHub Copilot. But it did change coding. Like 20 million developers use GitHub Copilot. That's a lot of developers. I don't think there's like any going back. The generation of developers nowadays coming out of university just expect to tab to the end of every like line of code. They love that tab button. And what lesson can we learn from all of this? Well, we're going through a hype cycle, and I think the lesson is coding agents will change coding. Just like somewhere in the middle of all those predictions, like from it's a fad that will go nowhere to by early 2026, there will be no more software engineers. Somewhere in between. Because no one really knows what they're talking about. Claude Code started this explosion of command line-based coding agents I'll be speaking about today. And it was released in February, which is 7 months ago. So if someone says they know what they're talking about, then they have at most 7 months more experience than you. And I don't think someone with like 7 months of experience is an expert at anything. But that also means I have to give you a disclaimer. I don't know what I'm talking about. I have less than 7 months of experience on this topic. Anything and everything I say in this talk might be out of date within a few months. You have been warned. Don't take me too seriously. But this is where the fun begins. Most of you might probably write code at your job. And the most obvious way to boost your productivity if you write code is to get coding agents to write code. If you just heard the other talk, you know what I'm talking about. It's vibe coding. And I found from experience that like talking really loud about vibe coding in front of developers generates a mix of reactions. I have a theory on why. I think part of it is like the people who talk about vibe coding talk like really big about vibe coding. But my experience is like it's like a New Year's resolution. Everyone likes to talk about their New Year's resolutions, but by February, like you made a big promise, you just don't talk about it that much anymore. Don't ask me. I tried out vibe coding. It was pretty fun. It was even a little useful, but I don't vibe code that much at my job. I mostly just push artisanal handwritten code, like a craftsman. And it turns out most software engineers are like me. This is from the Stack Overflow it's still a thing apparently. The Stack Overflow developer survey from this year, most developers don't vibe code at their job. But there's something going on here because vibe coding is really, really popular. Like, these vibe coding startups were apparently the fastest growing businesses in human history. And it seems to be really popular amongst like the general population. And to be clear, that's a great thing, I think. A bit of a side note, but like the vast majority of the population can't code. I think this is like roughly 50 million developers, so like assuming the rest of the code can't code, the rest of the world can't code. I wish more people could code. That's my opinion. I think it's a really empowering skill. But we've been trying to teach people to code for years, and some people the reality is some people aren't going to learn to code. And a few years ago, or not a few years, like 1 year ago, it was kind of impossible to write a few hundred-line like Python script to automate part of your job, or to write like a 1,000-line JS game to play with your kid. But now that's possible for basically everyone. I think that's a really good thing. But we're left in the weird situation where the people who can't really code just love vibe coding, and the people who code for their job like don't love vibe coding. Something's going on here. And now I have to explain large language models, the type of AI model that powers today's coding agents. I don't want to talk about transformers and attention and just like say all these other jargon words in front of you, so I'm going to do what everyone else does and just like add sparkles and also dumb things down a bit. So here's how I view it. You give a large language model some text. You get back more text. Okay, fine, let's take away the sparkles. We actually get tokens. Like you give a large language model some tokens, you get back more tokens, just one token at a time. And like, what are these tokens? This is FizzBuzz going through OpenAI's tokenizer. Tokens look like this. And large language models generally allow inputs of up to 200,000 tokens. That's called the context window. The input is called the context window. Now, as you can see here, a token is about like one word roughly. As you can see from the symbols, they kind of mess things up a bit, but one line of code is about 10 tokens, give or take. And in practice, though, like large language models have trouble as you fill up more of the context window. This is something called context rot. So 200,000 tokens is a bit generous. However, you know, every single day, apparently, there's a new model. Like the tech gets better all the time. And a state-of-the-art model these days can have a context window of 1 million tokens. But that's about 100,000 lines of code using the heuristic I said earlier. And that's just like not enough. Like most software engineers work in large code bases with more than 100,000 lines of code. I know Wikipedia says these are the notably large code bases, but hey, Google, that's not good. We're back. Google also employs a lot of software engineers. So what ends up happening is companies with large code bases employ most software engineers probably. And my experience is writing a few thousand lines of code from scratch is a very different problem from writing code in a very large code base with millions of lines of code, where shipping too many bugs too frequently will lose someone a lot of money. So I'm going to make a bold claim. The biggest productivity boost you'll get is probably not from writing code. Few software engineers actually use AI to write code, and this is just the software engineers who use AI a lot. Okay, I didn't actually give you a productivity tip, but here's where the fun actually begins. Here's how I personally use coding agents to be like slightly more productive. Number one, searching the code base. So I know I just claimed that these large language models can't handle more than 100,000 lines of code, but neither can I. I work in a large code base. I can't name every file off by heart. What I do is I use the search bar. Something's really going off with the internet. Let me go back. Can I continue? Oh, no. Right-hand side. There we go. Continue. There we are. Yeah, I use the search bar. And that's also pretty much what they do as well. Claude was one of the first large language models to get really good at coding. And they got really good by calling tools. Tools like search a directory or read a file or edit a file. Now, I'm going to give you an example. I know very little about Django, the Python web framework. I've used Flask more, but I just really wanted to know how select for update is implemented in the Django ORM. No reason other than I needed an example to motivate this. This is Gemini code. I recommend Gemini code to beginners just because it has like a super generous free tier. And if you're cheap like I was when I was preparing this, it might help as a good cost-free way to introduce yourself to this technology. So I asked Django, how is select for update implemented? And just look at it go. Now, I'm not expecting you to read all this slop, but take a note of the tool calls. So it's searching text and it's reading a file, searching text again and it's reading another file, and so on and so on. If you unroll that, it kind of looks like this. I give it a short prompt. Gemini starts running. It decides to call a tool to search for some text. It pauses. Something else goes and searches for the text. It goes back to Gemini. Gemini's like, I found a file. I want to read that file. It calls another tool. And then Gemini starts running it again, and then eventually decides to just return an answer. Yes, I skipped a few steps. There's a lot of tool calls sometimes, but that's the gist of it. And it eventually gave me an answer. I did have to tell it to be more concise so I could fit on the slide, but it found the answer in the end. Now, Gemini code and Claude code are AI agents, you might call them. You might have heard of that term before, AI agents. You might be wondering, what is an AI agent? It's probably one of the most ill-defined terms around nowadays. Anything that has a sprinkle of AI is called an AI agent. I've heard dozens of definitions, but there's a definition I really like, which is an AI agent is just a large language model calling tools in a loop. A tool like search code or write code to a file or search the web or whatever, but they're just calling tools in a loop. Cool. Now, the second thing I like to do is debugging stack traces. Maybe someone here will surprise me, but I haven't met that many people who just love debugging stack traces. Thankfully, you don't really need to that much anymore because, well, here's a slight digression, but as a general heuristic with large language models, one that I use a lot is that going from many words to a few words, generally pretty good. Going from a few words to many words is a bit more sketchy. This is a pretty common joke about AI. I'm going to write a single bullet point, I'm going to turn that into a long email, and then you're going to take my long email and turn it back into that single bullet point. I think that's a bit unfair because turning a single bullet point into a long email is begging the model just to make stuff up. You're telling it to write slop. But when you go from a long email to a single bullet point, it might miss a crucial detail, but it's compressing a lot of text. It doesn't need to make stuff up because it has a long email. I think that debugging a stack trace is fairly similar. So a stack trace has a lot of lines. Generally, 1 or 2 lines actually matter, and you can tell fairly quickly if you found the right line. That just saves you the time of reading the entire stack trace. Side note, this is not important. I didn't know what to put on these slides because who would actually read the stack trace? This is just some software gore I found. Here's some more software gore. this time with a password being leaked in a stack trace, just for fun. But yeah, the cool thing I found with debugging stack traces using coding agents is you might genuinely be 10x more productive. Like 10x programming is a thing that doesn't really work out because like most of your time right now is probably not debugging stack traces. It's like 2% of your time, and now it's 0.2% of your time. But one survey found that just debugging stack traces was the single biggest time saving from using AI tools, just because it's so radically efficient. But there was a caveat. It helps to choose boring technology. Some people might have heard of this motto before. Basically, prefer popular frameworks with lots of support rather than a cool new library I published yesterday that no one knows about. Coding agents kind of turbocharge that a bit. Like more code in the wild means more training for the large language models. That means they understand your tech a bit better. You'll have an easier time with a popular framework like Django than a library published like this year. It does make me sad sometimes knowing that if I ever wanted to make a cool new Python web framework, I'll have a hard time competing against Django, but I think the ship has sailed. And of course, luckily for everyone here, this is the Python conference. Python is a boring technology these days. Last year, it overtook JavaScript as the most used language in public GitHub repos. Python is generally the most well-supported language by coding agents. OK, number 3. You want to fix some bugs. This seems to be like the bread and butter for casual coding agent users, like just fix my bugs for me. But I suspect most casual users aren't doing it super well. Like, picture this. It's the first day in your job. As part of your onboarding, you just get assigned a few bug fixes, and your boss comes over and just says 2 words, fix this. That's all they say. They just say, fix this. Personally, that would suck. But I've seen a lot of developers and just like try debugging by just saying, fix this. And you would not say that to a new hire on the first day of their job with a few new bug fix tickets because they have no context. Don't really expect coding agents to be any different. Like a newbie on their first day needs context just like a coding agent. Or as I like to say, context is king. The heuristic I use is just give as much context as you would to a newbie on their first day. I have seen coding agents fix very complex bugs from detailed bug reports, even with images. They can read images these days. But I have not seen many coding agents fix many bugs from like a 1 or 2 word bug report. 2 tips I recommend to ensure you have enough context is just like prompted to ask clarifying questions. They sometimes won't by default, but literally just add like, if anything's unclear, ask me a few questions before going ahead. It's the same way that I've onboarded newbies at work a few times, and the newbies that ask more questions generally onboard a bit faster. The other thing is, this might sound a bit crazy, but literally just talk to it. People usually speak faster than they type. So use your microphone and use a transcription tool and literally talk to your computer. Large language models understand language really well. They'll get past grammar mistakes or transcription errors. They won't get past a lack of context. Just a warning, though, that if you do it in an office, you might get some weird looks. But I've done it for you. And last thing is, avoid context rot. So as I said earlier, these large language models struggle a bit as you fill up more of their context window. And if you fill it up entirely, it's kind of game over. Yes, coding agents can search really well. They can call tools and so on. But if you're working in a sufficiently large code base, my experience is 100,000 lines of code with no context is surprisingly small. So you do want to protect your context window if you can. The most obvious way to do that is these agents are configured to read from a markdown file. In Gemini, it's gemini.md. In Claude, it's claude.md. It's just the go-to place to dump tips and tricks about your code base. And often, the coding agent will like offer to do it for you if it's the first time. But might be hit and miss. This is like Gemini code is open source, and so is that like Gemini.md they use to work on Gemini. It's a bit meta. What you'll mostly see, it's about running command line tools and style conventions. Okay. Number 4, writing code. I know I said earlier that the biggest productivity boost won't be from writing code, but I confess I have used coding agents to write code. I have committed that code. But you might have heard people complaining very loudly that Claude Code just loves deleting unit tests. I'm one of these people, by the way. I've seen it firsthand. Or that they might just delete your database once in a while just for fun. And that's why I have trust issues. I have trust issues with these coding agents. Like, maybe I'll trust them in the future when they get better, but right now, the future isn't here. I've learned that the hard way too many times. And I'm not alone. Like, very few developers seem to highly trust AI. Like, 3% seems like a small number to me. But why do coding agents just love deleting my unit tests? Okay, so now I have to talk about how large language models are trained. This is going to be a massive oversimplification because there's so much you can fill into 30 minutes, but one way of thinking about it is large language models are trained to maximize a reward function. A reward function like write code that passes the unit tests. You might see like the flaw in this, but we'll get there. The success of ChatGPT, for example, is credited with just like getting trained at getting really good at writing text that humans like as measured by that little thumbs up or thumbs down button. But in practice, writing like ungameable reward functions is really hard. And sometimes large language models find an easier way to achieve the reward without doing the hard work. That's called reward hacking. And sometimes coding agents just figure out, like, why do I have to fix the tests when I can just delete the tests? It's obvious, right? Just 0 tests pass successfully. And that's why my experience is you won't save that much time generating 1,000 lines of untested slop to a critical system that you can't go down because you're on call and you like to sleep. I have tried. It was not fun reviewing every single line and fixing all that code. My general rule is the time saved with coding agents is sort of inversely proportional to the time spent verifying. Like, that's why I really like using coding agents to debug code, because bugs are usually 1 or 2 lines and usually obvious in hindsight. It's just finding those 2 lines is really hard. It's just easy to verify, so you save a lot of time. Having said that, you can save time using coding agents to write code. For example, you'll save more time refactoring code if there already exists a comprehensive set of unit tests. Just make sure they don't get deleted. If you don't have a comprehensive set of unit tests, just be prepared to review every line of code very carefully. You can try to ask coding agents to write some tests beforehand. That can work, but in my experience, it's still a bit of a slog than a set of coding agents that you really, really trust, a set of tests you really, really trust. And coding agents are also really good at writing shell scripts. Like, remember vibe coding from earlier? Running a few hundred lines of code from scratch is bread and butter for these things. And most shell scripts don't do anything too spicy. Most of my shell scripts just transform a CSV file to a different CSV file, maybe like add a comment or something. Nothing too spicy. And the neat thing about those types of shell scripts is you can just look at the output. Does the output look sane? If so, you don't even need to look at the code. Yes, number 5, generating synthetic data. So large language models are really good at making stuff up. Stuff that is realistic, but not real. And a couple years ago, I was working at Canva on autocomplete. And we were gearing up to announce a design generation tool called Magic Design. give it the prompts, it will create a presentation or a social media post. But there was a problem we had in autocomplete, which is the vast majority of search queries are fewer than 5 words, like usually 1 or 2 words. Magic design prompts are more than 5 words. So how do we get autocomplete to work on magic design? We literally just made stuff up. We got one human, not an engineer, by the way, to write down like several hundred prompts that were realistic and real, and then used ChatGPT to generate like thousands of more prompts from that like seed. I'm skipping out over a lot of hard work here, but it kind of worked. And we had solved the cold start problem in like these recommendation systems where autocomplete is almost magical if you have a lot of data, but if you don't have any data, you're in a hard spot. Large language models can help bootstrap across that like bridge by generating realms and realms of fake but realistic data. Yes, real data is better than fake data, but fake data is better than no data. Okay, those are my 5 big tips, and I want to ask, what did we learn? My takeaways are, coding agents are really good at some things, but they're also really bad at other things. But you'll only find out that a coding agent is good at something by wasting time. Productivity doesn't only go up. So, you will waste time figuring out that putting a coding agent up to a task was just a really bad idea. But then you'll save a lot of time like figuring out it's really good at something. And that's it. If there's still time, I'm happy to take any questions.
Thank you very much, Michael. Before we have any questions, if Tom Allen is in this room, could they please head to next door for their talk? Thank you. We have a couple of minutes for questions. Do we have any questions? We have a question over here, about halfway down.
Thank you very much. Hiya, I'm Renee. I work at Microsoft
Nice.
with the wonderful world of Copilot. And I've been recently using, as you showed with Gemini, the Gemini.markdown, we've got Copilot instructions.md going on, both at a global level for all of your repos and at a repo level. I like including things like, make all my variable names in Australian spelling and things like that. Or like this project is using Fast API. I was wondering if you have any overall tips that you would include in those kind of instruction data sets, markdown files.
Yeah, sure. I think the best tip is generally get it to develop a plan and then get you to approve that plan. Yeah, that's my biggest tip. I've sometimes used, I have a lot of command lines which are really, really slow, and sometimes it takes a long time, and I realize, oh, it's because I said run all the tests, and then it runs all the tests, and I have to wait 5 minutes. So, it differs a lot depending on your project. But main one, get that to make a plan.
One more question?
Nope.
Just up here at the front.
Great talk, Michael. I don't think you mentioned anything about using AI for code reviews. Do you have a take on that?
My experience is they are really good at nitpicks. Really, really good at nitpicks. But again, the biggest mistake is people just expect it to be good, but you have to kind of refine it with a lot of explanation of what do you want it to review exactly to get good results. Otherwise, it'll just be in Python, we expect variables to be like this, and you did not do that. You should do that. That's my experience, at least.
Cool. That's all the time we have.
Thank you
very much, Michael. Here is your mug. Are you around for the rest of the weekend?
Yes, I am. Yes, I am.
Thank you, Michael. Cool. We've got